Poor intelligibility of sung text is a common challenge for classically trained singers, particularly in reverberant rooms with orchestral accompaniment, which can mask sung text. In this study, the hypothesis is posited that extending the closure duration of voiceless plosives in voiceless plosive vowel sequences sung in reverberant rooms, for example in a concert hall, enhances the recognition of plosives. Pronunciation of plosives starts with closure phase, during which the ear pressure behind the closure is raised while no sound is created. Next, the burst phase follows, which the air pressure is released with explosion-like noise. According to our hypothesis, when the plosive's closure is held longer, the concomitant reverberation tail from the preceding vowel has longer time to decay before the plosive burst is pronounced, thus reducing the masking of the burst by the reverberation tail and improving the recognition of plosives. To explore the impact of plosive closure phase duration on plosive recognition, we conducted perception tests where the participants were asked to identify plosive within plosive vowel sequences that were sung on a single pitch and where the duration of the plosive closure phase was intentionally varied. To create the stimuli, we asked two classically trained singers, professional singers, a mezzo-soprano and a tenor, to sing series of a-ka, a-pa and a-ta sequences, which differed by the pitch of vowels. In the limits of one series, the pitch remained the same. The mezzo-soprano produced two series, G4 and F5. The tenor sang only one series, G3. As a next step, we manipulated the plosive closure phase durations in the stimuli with the help of PRG software. We decided to use the plosive closure durations 60 milliseconds, 150 milliseconds, and 260 milliseconds based on the database from a previous study on speech sounds durations. Then the PRG vocal toolkit was used to create stimulus sets with stimulated reverberation, church or big room, and with or without brown noise to mimic the masking effect of an accompaniment. We had 34 listeners, 11 males and 23 females, aged from 21 to 68 years. Stimuli were administered them via the headphones, and participants had to click one of the four buttons, K, P, T, or a question mark if they could not decide, on the computer screen according to the consonant they heard between the vowels. When pooling responses in the perception test across all acoustic conditions, plosives, test series, and burst intensities, the proportion of correct responses increased from 61 to 67%, as the closure duration of the plosive increases from 60 milliseconds to 150 milliseconds to 260 milliseconds. This change was statistically significant according to the chi-square test results. However, when re-examining the results of separate acoustic conditions, the greatest increase occurred in the case of a big room, from 59 to 83%. It was more in the case of a church, from 58 to 69%, and modest in the case of big room when also brown noise was added to the stimuli, from 47 to 50%. Also, plosive recognition improved as the pitch of the stimuli decreased. We may conclude that in reverberant acoustics, the recognition of voiceless plosives in sung plosive vowel junctions will improve if the vocalist extends the closure of the plosive. Further research is needed to determine whether singers indeed use the lengthening of plosive closures to improve the intelligibility of sung text in reverberant acoustics. Also, it remains unclear whether the lengthening of the plosive closures worsens the legato and naturalness of the text's prosody in the context of a specific language.